Starting Chapter 6, Chapter 6 is all about radical functions, and the first section, 6.1, we are going to evaluate the nth root and rational exponents. Now we already know about the square root, and we're going to take the concept of a square root a little bit beyond what we already know. You already know about square roots. If we had the square root of 9, you know to think what number times itself gives you 9. And I hope you would say 3. We're going to take that concept a little bit beyond, and now we're going to be talking about cube roots, fourth roots, and so on and so on. So something that was a cube root, like if we took the cube root of 27, we would then think what number times itself 3 times gives you 27. If we were looking at a fourth root, we think about what number times itself 4 times, and so on and so forth. We're also going to learn that you can rewrite this a different way. A square root, think of a 2, so that has a little 2 there, is the same as taking 9 to the half power. The cube root of 27 is the same as taking 27 to the third power. You know the square root of 9 is 3, and the number times itself 3 times that give you 27 is also 3. So we're going to apply these rules in this section. This is a table of some nth roots, so if you want to pause the video and write this down in your notes, it might help you in the future. So let's actually find an nth root. Now when we're dealing with these, the nth root, the n is going to be your root, and the radicand, or the number under the radical, is going to be denoted a. So when they say n equals a certain number, a equals a certain number, n is the root, and a is your radicand, or the number under the radical. So here they want us to find the cube root of negative 125. Now let me just tell you right now that if n is odd, so if we're looking at an odd root, you will always have one real nth root. So there's only one root. In other words, there's only one number times itself 3 times that's going to give you negative 125. And that number is negative 5. If we took negative 5 times itself 3 times, we would see negative 25 times, or I'm sorry, negative 5 times negative 5 gives us 25 times a negative 5, which would give us negative 125. So the cube root of negative 125, or can also be written negative 125 to the third power is equal to negative 5. This notation is important to know that all of this is the same thing. That is important. Let's look at another example with now an even root. So now we're looking for an even root when n is even. If a is greater than 0, so if we're looking at something under the radical that's other than 0, you will have 2 real roots. So here we are looking at the fourth root of 81. So what number times itself 4 times is going to give us 81? We can also write this as 81 to the 1/4 power. That's the same thing. Now there's actually 2 numbers that are going to give us this. We can think about 3 times itself 4 times, but negative 3 times itself 4 times is also going to give us positive 81. That is why when you're working with an even n, there are 2 real roots, because a negative times itself an even number of times will give you a positive number. So this answer is actually plus or minus 3. It can be negative 3 or positive 3. So there are 2 roots for this answer. The next thing we're going to talk about is rational exponents. Now remember that rational means fractions. So we're talking about fraction. So let's say we have some number a to the power of m over n. N is going to be our root, so the denominator of our fraction is our root. And m, our numerator, is our power. So if we have, for example, 4 to the power of 3 over 2. 3, our top number, is our power, and 2, our bottom number, is our root. Now this means one of two things. You can think about it two different ways. Number one, you can think about it as the radical of 4, so the square root of 4, because 2 is our root, then all to the power of 3, because that top number means the power. Or you can do it the other way. You can think about 4 to the power of 3, and then the radical of that entire thing. Either way you do this, you're going to get the same answer. You can take the square root of 4 to the third power. Square root of 4 is 2, to the third power is going to give you 8. Or you can think about the square root of 4 to the third is 64, and the square root of 64 is 8. So either way, it's the same thing. So those are how rational exponents work. So let's talk about a little bit more on notation, just to make sure we get the hang of this. So let's start with radical notation, because that's what you just worked with. Let's say we have 16 to the power of 3 halves. You can think about it a couple different ways. I like to do the root first. So since there's a 2 in the denominator, that means we have the square root of 16. So we have the square root of 16 all to the power of 3. Square root of 16 is 4. 4 to the third power is 64. Now let's do the same problem using exponent notation. So let's say we still had 16 to the power of 3 halves. Now using exponent notation, remember that the square root is the same thing as having a power of a half. So I can rewrite this as 16 to the half power all to the third power. Now you can even check your work here to make sure you're right and go backwards using things we learned about last chapter. Remember, if you ever had, I'm just going to rewrite this, if you had a power to a power, you multiplied the powers. So 3 times a half gives you 3 halves, which would put you back where you need to be. That's just checking your work. Going on with this problem up here, we have 16 to the half power, same thing as the square root of 16, which is 4, to the third power, which is 64. So we have two problems, different notation. Important to be able to flip back and forth between those two. So let's evaluate another example, now with a negative exponent, just to make it a little bit more complicated. And I'm going to use both radical notation and rational exponent notation. First, for the radical form, we have 32 to the power of negative 2 over 5. Remember that whenever you have a negative exponent, you need to flip that, put it on the bottom, to make it positive. So our first step would be put it in the bottom, the denominator, so we can make that exponent positive. Next step is, remember the 5 here is the root, and this 2 is the power. So we can rewrite this as the 5th root of 32 all squared. The 5th root of 32, think about what number times itself. 5 times gives you 32. It's actually going to be 2. And that bottom number is still squared. So your final answer is 1/4. Now I'm going to do the same thing, except I'm going to use rational notation. So first step is still flip your number so your exponent is in the bottom, so it becomes positive. Now instead of writing the 5th root of 32, I'm going to write 32 to the 1/5 power, which is the same thing, all squared. Now 32 to the 1/5 power is just like thinking what number times itself. 5 times gives you 32, which again is 2. Bottom is still squared. And the answer is 1/4. We're going to be using our calculator in class, so I'm going to skip that little section. I want to go on to solving equations using the roots. So let's practice solving equations. We want to solve this equation for x. I hope by now you know how to start this. Get your x by itself, so add 10 to the other side. We have 2x squared equals 10. Divide by the 2. We have x squared equals 5. So to finish this out, the opposite of the squared would be square root. So your answer would be x equals plus or minus the square root of 5. Now, unless the directions tell you, please leave your answer as a square root, not a decimal. We want the actual answer, not an approximation. I have one last example for you. Again, we're solving for x, so we want the x all by itself. Add the 10 to the other side. We have x minus 2 all to the power of 3 equals 10. Now, once you get to this step, you have something to the third power. To get rid of that third power, now instead of taking the square root, we're not dealing with squared, we're dealing with something cubed. So you're going to take the cube root of both sides. This is supposed to be a 3. So now what you're left with is just what's under the cube root. X minus 2 equals the cube root of 10. Now notice after I took the cube root, I didn't write a plus or minus here. If you remember earlier, I said if we're dealing with, whoops, I erased part of my cube root. If we're dealing with odd roots, there's only one root. So it's not plus or minus. If you have even, so a 2, 4, 6, then you're going to have plus or minus. But if you're dealing with an odd root, there is no plus or minus. There's only one answer. So to finish this out, add 2 to both sides. And your answer is x equals the cube root of 10 plus 2. Now I know that looks really odd, so if the book asks you for a decimal, actually find the cube root of 10 and add 2 to get your approximation. And if we did that, this is approximately 4.154.